Alright, hi you guys. Today we'll be talking about chords and arcs. Okay, a chord is just a segment that goes inside of a circle and it doesn't go through the diameter. Okay, and it also has some cool relationships with its related arc right here. Okay, alright. So, first off, let's take a look at the first one. Okay, here's something cool. Let's put some actual letters to this. Okay. Alright, here's some cool things. If you know the two central angles. Now, I also want to point out that I will represent chords as C's and diameters as D's. So that's some really cool stuff to actually work with right here. Okay. Alright, so right here I've got some chords in here. You could actually call these radius chords. Or, you know, actually they're probably going to be more better known as radiuses. There we go. Let's move that back over there. Let's go R. There we go. Alright, so let's say that you have the central angles inside of a circle with some parts all drawn out. And these just look like just straight up radiuses. Okay, if these two angles are congruent, then here's some cool things. The arcs are congruent as well. Okay, so that means that these two will be congruent. They won't be the same. They'll be the same angle measure, but you get the idea. Plus, if I draw a chord from A to B and from C to D, those will also be congruent. So there's a couple of things that can be said just about this shape alone. Okay, so some really cool stuff that can be said. All right, now, over here, on this one right here, this circle with two chords that are congruent right here. Okay, that means that these arcs are also congruent. So I would just draw hash marks through them. Okay, so that's some really cool stuff right there. Alright, and then if we focus down here on the bow tie theorem, I like to say if you're making a bow tie, you're probably dealing with some really nice congruencies. Okay, now if you notice I didn't draw it through the center and I didn't notice it drawn through the center, but right off the bat these two angles are congruent. Why? Because of vertical angles. Okay, now here's the other cool thing, is that this angle will be congruent with this angle, and this angle will be congruent with this angle. So some really cool stuff. Now, not much else can be said about this. You can't say that they're similar or anything, but I mean, they probably are going to be similar because we do have congruent angles inside of here, and we probably would use the double A similarity theorem. But anyways, what we could actually say is that this angle is equal to this angle, and this angle is equal to this angle. Okay, can't say anything too much about the other sides. They could be congruent, they could be similar. Who knows? Alright, now if we take two chords, okay, and we draw a perpendicular line to the actual center of the actual circle, then what has actually happened is that I have made two congruent segments right here. Okay, so not only are they perpendicular to the actual chords, but they're actually congruent to each other. Now, another thing that can be said about this is that if I know that these two lengths are similar, then I definitely know that these two chords are congruent. So that's a little nice fact to have in hand, okay, as you're working with this. Now we get to the granddaddy of them all, okay, in which we're dealing with a diameter and a chord that is going to be drawn through. Okay, so if this is a diameter and I know that this chord is perpendicular to it, then I know that this is equal to this, and this arc is equal to this arc. So some really cool information that you can get from that. Okay. Now also the converse is true. If I know that this is congruent and this is congruent, okay, and I know that this is a diameter, then I can also say that this is perpendicular. So that's some nice information. I can have that. Okay. And I can also say that this line is a diameter by just knowing that information. Okay. Well, actually, if I know that this is a perpendicular if this is perpendicularly bisected by this line, then I can say that this line, this red line, is actually a diameter, and it should have the center somewhere on there. Okay, and it's probably going to be the halfway point, just like what we talked about. Okay, so some really interesting stuff that you can do. Now, I do want to point out that this one is really cool because you can actually make some right triangles in here and use some Pythagorean theorem. Okay, so just so you understand, you might be asked to find some Pythagorean theorem problems, and just so you know, because of the hypotenuse, leg, well, actually because of SAS. Okay, let's put this through there. There we go. Okay, because of SAS, these two hypotenuses are also going to be congruent. Okay, so some really cool stuff that you can do with circles and tangent lines in there. Okay, all right, that's it for chords and arcs. I'll talk to you later. Bye.